Okay, so let's take a look in this screencast at how to approximate an irrational number. Let's think for a moment about, the number square root of 3. How big is it? Uh, Really, the way we approximate the square root of 3 is by trapping it. We would look to trap 3 between two perfect squares. So we know that 3 is greater than 1, but less than 4. So we know that the square root of 3 is between the square root of 1 and the square root of 4. So we know that it's 1 point something, and it's probably closer to 2. So then we ask our calculator, is it between, oh wow, you don't want that. Is it greater than 1.7? Yes. Is it less than 1.8? Yes. So we know that the square root of 3 is 1.7 something. And then we would decide, okay, it's between 1.7 and 1.8. It appears to be closer to 1.7 because 3 is 0.11 away from this and 0.24 away from that. So maybe we would try something less than 1.75, and we can trap the value this way. Now we know that the square root of 3 is greater than 1.73, but less than 1.74. And it's really close to 1.73 because the distance to 3 here is 0.0071. And so we would try 1.73 and then something very small. So we can trap the value of the square root of 3 between so-called consecutive decimals. There's no such thing, but we can think about them as consecutive to the 10th place or to the 100th place and so on. So we can find a decimal approximation for the square root of 3 in this way. It's an irrational number. There's no pattern. It'll never repeat, but we can get an approximation as good as we'd like by trapping between values. Just to illustrate slightly differently, let's think about the cube root of 5. So the cube root of 5, so what is that? Well, what does cube root mean? Well, cube roots mean we're looking for perfect cubes. 1 cubed is 1, 2 cubed is 8. So the cube root of 5 is somewhere between 1 and 2. And probably about halfway, so I wonder what 1.5 cubed is. Well, 1.5 cubed is 3.375. Well, 1.6 cubed, that's still not big enough. 1.7 cubed, that's still not big enough. There we go. So now we have trapped the cube root of 5 between 1.7 and 1.8, probably closer to 1.7. So 1.7 is less than the cube root of 5, which is less than 1.8. And it appears to be pretty close to 1.7 because this is pretty close to 5 and that's not pretty close to 5. So maybe we try 1.72 and that's too big. And 1.71 is too big. So now we've trapped between 1.7 and 1.71. And we can continue the process. It's very close to 1.71, so maybe I'm looking at that's too big. Oh, that's still too big. 1.709, that's smaller. So now we're trapped between 1.709 and 1.71, and we can continue in this way until we figure out a value that's approximately the cube root of 5. So it's 1.709 and change. Well, I hope this is helpful, that it explains some things that you've read in your textbook, and I look forward to finishing our course strong together.